Conversation is being
here.
recorded.
Aaliyah is here. Madison. Maddie, are you here? Hi, Maddie. I got Dalton here. I got Alexis here. I got Hannah here. Derek, are you here? Derek, are you here? No? Alrighty.
Ow, my back.
No, that's not normal.
My back.
Maddie is
Oh,
here.
my
Hey,
back.
Maddie.
My back.
Are you okay, Austin?
Oh, okay. I try
Alright.
do that Bioman meme.
Okay, guys, today for math, we are going to do telling time. I have several telling time worksheets for you. So what I'm going to do is I'm going to push them out to you. And then if you have questions about specific ones, I want you to raise your hand and ask. And I'm happy to go over any specific questions that you guys have. You can also send me a private message if you don't want to like ask out loud and you just want me to go over it in general, that's fine too. So the first one is going to be telling time to the hour. Let me drop the link in the chat. And they are also going to be on your ULS dashboard. After you do telling time to the hour, you have a telling time to the half hour.
All right, thank you.
What do I do with a cat that throws up every time he eats?
That was the same one. Hold on. Sorry. Here you go. Telling time to the half hour. And then you'll do telling time to the 15 minutes. The quarter hour. Telling
Just
to
the
5
same
minutes,
one.
and
Yay.
then telling mixed times.
Just
What's your
same
question,
one.
Austin?
You post the same one links 3 times a load.
Okay, so you guys have 1, 2, 3, 4, 5 worksheets to complete. But again, I am here to help you. So if you have questions about any of the problems, please let me know. Dalton, hello, what's up?
Hello. Hey, I go check my mail for my grandma.
Of course.
I didn't yet.
Fine.
That's wonderful to hear. Anyway,
Keep your feet dry. It's cold out.
It's not that bad out. The wind's not blowing today.
Okay.
Oh, it's warmer than it has been, but the snow is deep.
Uh,
Don't get any
I will
snow
call
issues.
you back on this number, and if you answer, I'll talk to you. If you don't, I won't.
Oh, well, no, Carol, we cannot give you the callback number because only the licensed agent can give you that.
Yeah, okay, that's what I thought. What to do about an adult cat who vomits every time he eats?
Hi AJ, welcome. We are doing some telling time math in ULS. The links for all of the assignments are in the chat box. And then as people get questions, you guys can just raise your hands and let me know, and I'm happy to help with any problems. Austin Neal, do you have a question?
No,
Okay.
It's the same one.
I just had to switch computers.
Oh, okay.
When you go do something or what?
Miss Tracy, you're muted.
Thank you. Austin, you have 5 worksheets in the chat box you're supposed to be working on about telling time. Do you see them?
Yeah, it's the same link over and over and over and over and over and over and over.
It's saying wait?
No, the same link.
He's saying it's
no.
the same link.
No, it's not the same link. It's 5 different links.
I click on them.
Uh-huh.
I see them the same link. No difference.
So the first link is going to take you to telling time to the hour. The next one is to the half hour. And then 15 minutes, 5 minutes, and mixed time. AJ, you need your password. Madison, you're done with all 5?
Okay.
Yeah.
Okay, let me check them. AJ, do you need your username too?
My username?
Nope, I'm talking to AJ.
Can I get my A+ now?
Not yet, Madison.
Okay.
All right, there you go. I just reset it, AJ. Madison, you still have 7 assignments on your dashboard.
Just still forgot. Hello?
Yeah, Madison.
Just forgot.
You forgot what?
I just forgot something.
Oh.
Do I get it wrong?
No, why don't you go ahead and work on some of that other stuff you have on your dashboard, though, okay?
Okay.
Hello?
Hello, this is Paula, Pickles Plumbing and Electrical.
Uh-huh.
I know you know the electrician's on the way. I'll say about 45 minutes to be there.
Oh, okay. I tried to call you earlier. My son was one did the calling. I thought I could get your number, but I couldn't. And they gave me a Kansas number, and I knew that one.
Okay.
But what is your number so I can write this down just for the future?
816 345
Okay,
4 o'clock p.m.
I'll just shut the family door and then cut those dogs in half. I just got 3.
12 o'clock p.m. 11 o'clock a.m. 12 o'clock p.m. 5 o'clock p.m.
If you guys are completely finished with your ULS, if your dashboard
5
is all the
o'clock
way cleared
p.m.
off, you can go into IXL and work on your math skills.
3:25 p.m. 7 o'clock p.m.
Yeah, I know. I'm shutting the door. The man's coming.
3:25 p.m.
She said it's about 45 minutes away.
7 o'clock p.m.
But I'm gonna shut the door so I can get all the dogs in one room, or I'll put them in a cage. That cat. I've been trying to read up on that on my Google. That cat is every time he eats, he throws up. And they said maybe it's irritable bowel.
10:30 a.m.
Or maybe he's eating too fast.
8:30 a.m. 10:30 a.m. 11:30 a.m.
Check on some more.
11:30 a.m.
I'm tired of cleaning up back there. I just got through cleaning another mess up.
11:30 a.m. 4:30 p.m. 3:30 p.m. 4:30 p.m. 1:25 p.m. 3:30 p.m.
Yeah, something. Or getting some different food. They said, I don't know, I read a bunch of stuff.
Seven 15 a.m. 8:15
Miss
a.m.
Tracy,
Yes, sir.
can I share my screen with you?
Sure.
8:15 a.m. 12:45 p.m.
Oh, hold up.
2:35 p.m.
I don't know what to do on these three right here.
11:45 a.m.
Okay, those are the ones from yesterday. Were you not in math class yesterday?
2:35 p.m.
Oh, I was. I believe I was.
Well, we all did
11:45
those together
a.m.
yesterday.
11:45 a.m.
Austin, do you have a small group meet up today?
3:15
Are you
p.m.
on my
Yeah.
small group? leader? Okay, we can work on it in small group, okay?
3:15
Okay.
p.m.
All right.
Thank you.
Mm-hmm. Alright, so guys, as you finish the Italian time worksheets, you can go into IXL and work on your math skills.
Nine 9:50 a.m. 9:50 a.m. 5:50 a.m. 10:50 a.m. 9:50 a.m. 4:00 p.m. 12:20 p.m. 1:20 p.m. 12:20 p.m. 1:20 p.m. 5:55 p.m. 5:55 p.m.
Remember, if anybody has any questions about the Telling Time worksheets, I am here to help you.
1:05 p.m. 1:05 p.m. 3:30 p.m. 3:30 p.m. 4:10 p.m. 3:10 p.m. 4:10 p.m.
Hey, Miss Tracy,
Yes?
can you send me my IXL password?
Mm-hmm.
I just need the password. That's it.
Okay, give me just 1 second and I will send it to you.
Thank you.
Mm-hmm.
I done.
All right, if you are all finished with ULS, you can log into IXL and work on your math skills. We have about 5 minutes left.
Wait a minute.
Austin, it's in the chat.
Okay, thank you.
Mhm.
In the chat, where?
Oh, sorry, Austin Neal.
Oh. Okay.
Miss Tracy, this AI sales subject is hard.
Oh, the IXL.
It's
What are you
called
working on?
capital the letters with the capital letters with the white short fail.
You can share your screen with me if you want.
Huh?
You can share your screen with me if you want. You want
Screen
to show me
with
what
you?
it is? Yeah, do you want to share your screen with me?
Yeah?
Okay.
How'd you click?
You have to hit present.
Percent. Left?
Do I hit step into the arena?
Weena.
Austin, share your screen. I
Okay.
thought you already did that.
Oh. I'll let her go, then I will send you mine.
Oh, is this Madison's screen or Austin's?
Oh crap!
Lessons.
Oh, it's okay, Madison. Okay, so Madison, you need to do this step into the arena, okay?
Do I have to do it by myself?
Yeah, so that's like a
Why it's
diagnostic
so
assessment.
hard?
You might want to sit with mom or dad while you do it, okay?
But my parents are busy.
Okay, well maybe do the step into the arena later tonight.
Okay.
Okay. Austin, Neil, go ahead and share your screen.
Okay.
I thought you already did that.
Can you see it?
Mm-hmm.
It says step into the arena.
Okay, scroll up a little bit.
That's
Click on the assessment tab. Next one over.
Oh, this one?
Nope, one in the middle. The one you were just on.
Oh.
Yeah, right there.
Miss,
Hold
I
on 1
already,
second.
I think I already
Let me
did
check.
that.
I thought you already did that. I'm gonna check.
Okay.
I think it's doing the same thing to me, Miss Tracy, too.
Is it asking you guys to do step into the arena again? All right, my friends, if you are all the way finished and you want to log off and go get a drink or something before science and social studies, we are switching classes. Austin and Hannah stay on if it's asking you to do that. I'm just looking at yours right now.
Alright, I'll see you in the class, Miss Tracy.
All right, see you in a second. Yeah, Austin, I don't know why it's asking
Me
to do
too.
that.
I go in the different class also.
Yep. I'll see you in science and social studies. Yeah, I don't know why it's asking you to do that because it looks like you already did it.
Easy. Difficult.
What's that about? Are you muted or are you on there?
Not on there. Not yet.
Alrighty. What are you doing? Timothy, hello, welcome back.
Welcome.
Alright. Do I have anybody who's logged in for small group today?
I do. I get into your small group today.
Austin,
Yeah, I'm in small group. I'm in small group today.
Is it small group
Log
too?
in? Cool. Anybody else gonna log in?
Is it the small group too?
Uh-huh.
Yep, I'm in that one today.
Cool.
I am.
Anybody else need to log in? Addie, you
Miss-
are awesome.
Miss
Yeah.
Tracy,
Yes, ma'am.
what are we doing in there? In this
Small group. Well, Austin wants to go over algebra, so we're gonna go over that really quick, and then whatever anyone else needs help with.
Okay.
Emily, do you have a question? Or are you
I'm
raising your
doing
hand because you come to
math
small
right
group?
now.
Alright. Okay, guys, so yesterday we started watching a video about aluminum cans changing states of matter. And where we left off, the can had gone through this kind of like metal grinder where it broke it down into smaller pieces. So whenever metal gets broken up from large pieces to small pieces, does it change states of matter? Does it change from a solid to a liquid or a solid to a gas whenever it gets broken into smaller pieces? Anybody? Or does it stay the same? Is it the same state of matter? Solid to
Million
solid.
tons.
All right. I'll do a quick poll so I can get some answers here since no one's answering. Large pieces of metal. Change to small pieces of metal. All right, is that stay the same or change state?
5, 6, 7, 8, 9, 10, 11, 12,
Changes.
14,
It
Hold on, I'm going to
changes.
do a quick poll and I want people to answer in the quick poll.
18, 19.
Remember, we talked about this yesterday in the video. So the big pieces of metal get broken into small pieces of metal. Does the state of matter stay the same? Does it stay a solid? Or does it change states? Does it change to a liquid or a gas whenever it gets broken into smaller pieces? If you think it changes into a liquid or a gas, that is B, orange. If you think it stays the same, it's still a solid, that is A, blue. I'm waiting for Aaliyah, Austin, Aaliyah to answer, AJ to answer. Hannah answer, Madison answer. Click on your quick poll. And for my friends that are saying A, you are correct. It stays the same. It is still a solid. Just because it gets broken into smaller pieces does not mean it changes to a liquid or a gas. It stays the same. All right, we're going to pick up where we left off.
Million tons. Recycling. In the recycling industry, what sets aluminum apart is its inherent waste. Thousands of tons of aluminum pour in daily, making this facility chemically consistent and tightly controlled. Ready to hundreds of kilograms of aluminum are pulled in and reduced to small fragments. The machine operates with precision, almost like it's pre-programmed. Rotating blades and crushing hammers assist the rollers, allowing the system to handle even thick, rigid aluminum parts. Under the glare of industrial lighting, streams of silver shards pour out continuously, cascading onto the lower belt like a sparkling stream. A vibrating screen system controls the output size, ensuring that all shredded aluminum is reduced to a consistent dimension, creating a stable, uniform feedstock for the next stage of processing. The shredded aluminum fragments are fed directly into industrial furnaces, the heart of the entire recycling process. Depending on the type of scrap and the desired end use, the plant may utilize reverberatory furnaces, rotary kilns, or electric arc furnaces. Each type is a sealed engineering system meticulously designed to control 3 critical parameters simultaneously: temperature, airflow, and material mixing rate. The internal temperature is maintained steadily between 660 degrees and 750 degrees, just enough to melt the aluminum without vaporizing valuable alloy components. Aluminum is loaded through the top hatch or a tilting chute, then constantly stirred by either mechanical paddles or controlled air injections. Some furnaces are equipped with heat recovery systems to maximize energy efficiency, while multi-stage filtration units treat exhaust gases to capture aluminum oxide dust and neutralize toxic emissions. Throughout the smelting process, thermal sensors and chemical analyzers operate continuously, acting as the system's senses, ensuring that every batch of molten aluminum meets precise technical specifications. The furnace is the climactic stage where everything converges: pressure, heat, chemical reactions, and mechanical systems all intertwine. A single misstep in control could turn an entire batch into waste. But when every element performs in harmony, the result is a stream of pure molten metal, ready to flow into the next phase of transformation. Even after the aluminum has fully melted, it still contains countless hidden impurities invisible to the naked eye. Aluminum oxides, furnace dust, paint residues, and even oils or greases left over from its previous life cycle. To eliminate these contaminants, the plant carries out a refining process directly within the furnace. The most common method is fluxing, the addition of a special flux agent into the molten aluminum. As it reacts, the flux bonds with impurities to form a light, floating dross layer on the surface. This layer is then skimmed off, either mechanically or manually, leaving behind cleaner, more refined metal. In more advanced systems, inert gases like argon or chlorine are injected at low pressure. These micro bubbles permeate the molten mass, trapping excess oxygen and hydrogen and carrying them to the surface for removal. The entire purification process runs under constant supervision by temperature sensors and control systems, ensuring that the molten aluminum reaches the necessary purity level required for the stages that follow. Once the molten aluminum reaches the desired purity, it is directed to the casting area, where it begins to take on its first defined physical form. This is the crucial transition from liquid to solid, from an amorphous metal mass to structured units that can be measured and transported. The aluminum is poured into molds made of steel, graphite, or specialized heat-resistant materials, depending on the product being formed. These could include vertical molds for ingots, horizontal molds for thick slabs, or continuous casting systems with water-cooled forced solidification. Pouring speed, mold temperature, and cooling intensity are all precisely calibrated. If poured too quickly, the aluminum can form gas pockets or surface cracks. If the mold is too cold, the metal may solidify unevenly, leading to internal structural flaws. Each parameter must be carefully balanced, much like keeping a steady stream flowing through a narrow gap. A slight deviation can distort the entire shape of the final product. In many modern facilities, the casting process is fully automated. Sensors continuously monitor pouring height, cooling rate, and surface temperature. Yet in some semi-manual lines, skilled workers still control the flow, a task requiring sharp instincts and split-second precision. Once the aluminum solidifies inside the mold, a hydraulic system gently pushes from the bottom, releasing the solid metal from the steel mold walls. Mechanical clamps grip the heavy ingot, often weighing dozens of kilograms, lifting it from the casting trough and placing it onto a parallel steel conveyor. The sound of metal scraping echoes throughout the foundry, while the surface of each ingot still glows faintly red from residual heat. One by one, the ingots are extracted in sync with the machinery, lined up neatly on the moving belt. Sensors quickly scan each piece, checking shape and dimensions to ensure no deformation occurred during demolding. From the casting area, rows of solid aluminum ingots begin their steady journey forward, perfectly aligned like metal bricks, marking the completion of a full production cycle inside the furnace. After being removed from the mold, the aluminum ingots are transferred into a preheating furnace to soften them, bringing the metal to the ideal condition for rolling. Once ready, each ingot passes through a set of counter-rotating steel rollers, where tremendous pressure flattens and elongates the aluminum block. This process is repeated across multiple roller stands, with the gap between each pair gradually decreasing. As a result, an ingot that originally measures several inches thick, often over 8 to 10 inches, is progressively transformed into a thin, uniform metal sheet. A fine water mist cooling system keeps the surface stable, preventing cracks or warping caused by excess heat. By the final stage, the sheet reaches its target thickness, often down to a few hundredths of an inch, and is guided forward into a continuous strip, then tightly wound into large coils. These standard semi-finished coils can now move on to further processing, such as cold rolling, cutting, or stamping, depending on their intended use. Among the countless products made from recycled metal, the aluminum can stands as the clearest proof of recycling's power, returning to store shelves just weeks later in an entirely new form. From massive aluminum coils, the can forming process begins by stamping thin aluminum sheets into flat, round discs known as blanks. These blanks are fed into a deep drawing press, where, in a single stroke, the metal is stretched into a small cup shape with thin walls and a flat bottom. The aluminum cup then passes through a series of ironing dies, with each stage making the can taller and its walls thinner until it reaches its final dimensions. The top edge of the can is slightly necked in to prepare for the lid attachment. Inside the can, a microscopic polymer coating is sprayed to prevent the aluminum from coming into direct contact with the beverage, ensuring both safety and flavor retention. Finally, the exterior surface is decorated using high-speed rotogravure printing, enabling thousands of cans per minute to be finished with precise labels. The completed cans are then stacked in batches, ready to enter the filling and sealing line. Once they leave the production line, aluminum cans appear everywhere, stacked on supermarket shelves, chilled in cafe ice buckets, popped open at lively parties, or quietly shared at family gatherings. Every day, hundreds of millions of cans are consumed worldwide, woven into the rhythm of modern life, from quick refreshment breaks to moments of shared connection. But the value of an aluminum can doesn't end the moment it's used. Once empty, it faces a critical crossroads: discarded as waste or placed in the right recycling bin, unlocking its potential for near infinite rebirth. In countries that operate deposit return systems, more than 80% of cans are recovered and recycled into new products within just a few weeks. In contrast, cans tossed into household trash become an environmental burden, despite being one of the most sustainable materials ever created. Ultimately, it's the consumer's choice that determines the can's fate. Every time you drop a can into a recycling bin, it's more than a small act. It's a vital link in keeping the green cycle alive, ensuring that aluminum continues its endless journey instead of ending up in a landfill.
Miss Tracy, you're muted.
Thank you, Bella. We watched that aluminum can change states of metal several times. It changed from a can to small pieces of metal. When that happened, it was still a solid. Whenever it went into the furnace and melted, who can tell me what state of matter it changed into? When they melted it in the furnace, what state of matter did it change into? Ella.
Like maybe a gas state of matter? In a different state of matter? It changed over time?
It did turn into a different state of matter. It turned into a liquid, Preston, yes.
Liquid,
it turned into a liquid. It melted and the metal became liquid. It could be poured and reshaped whenever it turned into a liquid. And that's exactly what they did. They took that liquid and they poured it into the ingot. And then it got hard again and turned into a what? Whenever the metal hardened, it turned into a what, Bella?
Solid.
Solid, very good.
Miss Tracy,
Yes, sir?
if you get that on your hand, that would hurt very bad.
Yes, if you put your hand in liquid metal, it would not be a good outcome. Don't ever do that. You're very right, Austin. All right, guys, we are just classifying some states of matter. So we are going to do this IXL activity together. You guys are going to participate through the chat. So you're going to tell me what state of matter we're looking at. And your choices are going to be A, B, and C. So the first one is A, the second one is B, the third one is C. And I'm pretty sure it all stays the same: solid, liquid, gas throughout. But I will. If you have your mic on, can you please mute yourself so that you're not disrupting the class? All right. Is the water in a bathtub a salad, a liquid, or a gas? Is it A, a salad, B, a liquid, or C, a gas? The water in a bathtub. Good job. And I want to see these answers pouring in
Session
from
is being recorded.
everybody.
What's a G?
Good job, friends. Is the air inside of a balloon A, a salad, B, a liquid, or C, a gas?
Miss Tracy.
Yes.
It sounds like you're saying salad. I'm sorry, but it sounds like you're saying salad.
Oh, stop making fun of her. That's not very nice.
I know you didn't mean that meanly, Hannah. Thank you,
Oh.
Austin, for sticking up
Oh.
for me. I know. There's a few words that I just kind of pronounce funny, and that is one
No,
of them.
it's okay. I do too.
But yes, it's a solid, like a hard, solid, something you can touch. Solid. Okay, yes to my friends who are saying C. It is a gas. Hello, Jack. Welcome.
Yeah, I have issues with the power and the internet.
I heard that. Are you doing okay?
Yeah, doing okay.
All right, bud. Well, we're glad that you're here. Right now, we are doing this activity where we are classifying states of matter so you can participate in the chat. We're saying, is the air inside of this balloon A, a solid, solid, B, a liquid, or C, a gas?
C.
Good job, guys. It's a gas. What about coffee? A cup of coffee, the liquid inside of your coffee cup, the part that you drink. Is it A, a solid, B, a liquid, or C, a gas? Good job, friends. B, a liquid. What about the bean? That's kind of funny because I was thinking if you're talking about coffee beans, what is that? A, a solid, B, a liquid, or C, a gas? Yes, my friends were saying beans are a solid. Good job. What about the air inside of a beach ball? Is the air inside of the beach ball A, a solid, B, a liquid, or C, a gas? Yeah, the air inside of it is a gas. All right, we're going to look at some more. See if we can get 6 questions in a row correct. What about sand? Sand on a beach, sand in a sandbox. Is that A, a solid, B, a liquid, or C, a gas? Yes, it is a solid. Now, sand is tricky because you can pour it, and whatever you pour it into, it's going to fill it up, right? It'd be that shape. But whenever you get down to the nitty-gritty pebble of a sand, it doesn't change shapes. You can't release it into the air. You can't pour a grain of sand into a cup. It is a solid. Sand is a tricky one. Good job, my friends. What about a baseball glove? A, solid, B, liquid, or C, gas? All right. You guys are doing great at this. What about a rain puddle? A puddle of rain. Is that A, solid, B, liquid, or C, gas? Good job. The air inside of a raft. A, solid, B, liquid, or C, gas?
Gas.
Yeah, the air inside is a gas. Great work. What about the air inside of a hot air balloon?
Gas.
Good. You guys are experts at this. All right, just a couple more. Is the wind turning a pinwheel? So the wind that's blowing around
Gas.
it. A solid, a liquid, or a gas?
I said gas.
Good job, guys. All right, we are going to end here. Tomorrow we will be doing an experiment.
Excel.
If you want to participate,
Decided to throw a party despite my constant urging. Your mom is
I would suggest doing it after we do the experiment, but you need to do it. So you guys can try it at home if you want. You'll just need 3 empty balloons.
business, Shorty.
Wait, what is it?
We're gonna do an experiment tomorrow.
Maybe I could
What do you
get
need?
Try it after we
to embarrass Riri.
If you have your mic on and you're got noise blaring, please make sure to stay on mute so that you don't have to shut the class. What were we saying?
About
If
the
you want to
project
try the experiment at home tomorrow, after we do it in class, all you will need for it is 3 balloons. All right, you guys have about 5 minutes just to kind of chat and hang out, ask any questions that you have. If not, I can break you up into tables to chat, or you guys can just unmute and chat. How's everybody doing?
Good.
Pretty good. How are you doing today?
I'm doing well, thank you. No one went to STAR testing, did they?
No.
Start. I have no clue.
Okay.
Oh, yeah,
Guys, if you get
wasn't supposed to do that, correct?
no, if you guys get messages about STAR testing, none of you are supposed to do it. Do not
Okay,
participate.
because Preston did get a message, and I
Yeah.
was wondering.
Miss Tracy,
Yes,
I
ma'am.
need to talk to you about something. Like whenever, like it's
Okay.
up. Like, it's,
We can stay on after class for just a moment.
okay.
Yeah, some of you might get messages about STAR testing. I try to make sure that they have an updated list of everybody, but there's a lot of kids at MODA, and sometimes it just gets lost.
Miss Tracy.
None of you need to do STAR testing. Yes, Austin.
If we have time after this, class, can I talk to you after you talk to Hannah?
Sure.
Okay.
Timothy, what's up?
Do you see the message that I wrote?
About playing the game in small group?
Yeah. Yeah.
We might be able to, but we're gonna do some other stuff first.
Okay.
Okay. Anybody else have anything for the greater good? All right. If you have
Not really.
if you have a personal question, stay on. We do not have 11th grade meetup today. We'll have it again next week, but we don't have it today. So yeah, we'll do that next week. We'll see you at 12. If you have a person,
Bye. See you at 12. You too.
I'll pull you to a table, and then Austin, I'll grab you after. Everyone else, I'll see you
Okay.
tomorrow.
Wait.
Miss
I had
Tracy,
speech-
we need to speak with you.
I had speech class today, though.
If you have speech, go to speech. If you have a personal question, just stay on for a second, and I will pull people to tables. Aaliyah, was that you?
Say yes, ma'am.
Yeah, ma'am.
All right, Aaliyah, I'll grab you after Austin.
just got out of the filling me. I don't know if I should take those or not.
It's about out. It's
6
about
hours
out.
has gone by.
No, not until about 1. But
And it's not 12 yet. Midnight.
We gonna go do something or
Yeah,
what?
Sweet midnight cat. Sweet Tommy cat. Yeah, you are a Sweet Tommy cat. Well, I put the phone somewhere. Oh, it's right in front of it. I've got a little line on where it's the pedal line.
unless you're up to running.
Huh?
Are you running?
Yeah,
You
yeah.
gotta go by the dermatologist and get your nose taken care of.
How about my nose?
You gotta go by the dermatologist and let her
Oh,
check it.
yeah.
That's very important. And I don't think she was. Doctor didn't know.
Which one? The one up in the city or what?
Dr. Carter said over there by Elite Cleaners, I think.
Where?
By Elite Cleaners?
I can't hear you.
I know.
He knew of another dermatologist.
And that's here.
Huh?
One that's here.
That's here.
That is here. In Warrensburg.
But
There's even one at the hospital, he said.
is it the hospital?
One.
Yeah, I gotta watch you too.
should have read the fine print on his permission slip, or better yet, Miss Frizzle should have taught them some common sense and to never remove their helmets while in space. Number 2, the kids are being sexually abused. This theory is pretty dark, and I'm sorry if I ruined your childhood for you, but doing the research ruined my childhood. There are a bunch of episodes where the kids go on field trips and witness multiple species during their reproductive time. Take, for example, the episode from season 1 called Going Upstream.
What? Is he some sort of car wash?
No. Don't eggs have to be fertilized by the males before they can grow and hatch?
The kids are converted into miniature size and they're put into salmon eggs. Later on, you can see that the male salmon ejaculates on the eggs while the kids are still in there. So what if these kids were actually being sexually abused on field trips and they just come up with these wild stories, you know, as a way to cover up from the trauma, and their parents never believe them? Miss Frizzle is a cold-blooded murderer, and this takes us to number 1. Alright, so it's speculated that Miss Frizzle is involved with a top-secret organization who built and manufactured a magic school bus. Miss Frizzle would take her students on crazy field trips so that she can test their endurance and strength. The weaker students would be brutally murdered, while the remaining students would be taken to a secret laboratory to have their minds erased. The organization and Miss Frizzle would teach these kids to be cold-blooded murderers who were trained to take control over Earth. This would explain why her class was so
Hey, Miss Tracy.
everyone made it out alive. Well, there you guys have it. I would hope this one landed you saying I never thought I'd get through this video. My throat is absolutely killing me. But if you guys made it to the end, you guys made it to the bloopers. I hope you guys enjoy.
Another wrinkle? That's irritating. But your retinol shouldn't be. Neuralay Retinol 24.
At the time of recording this video, a lot of people are getting very excited for Toy Story 4, which is set to come out this summer, 2019. Toy Story is perhaps one of the biggest movie franchises of all time. People all... The main group with it, and there will now be little kids who are about to experience Toy Story for the first time this year. It's great. We all love Toy Story, but how well do you know it? While I was reading about the latest movie coming out, I stumbled across some pretty strange theories about Toy Story.
I'm doing my goal walk. Be quiet.
Don't look like you're over there to me.
Look at the doing absolutely nothing.
At the time of recording this video, a lot of people are getting very excited for Toy Story 4, which is set to come out this summer, 2019. Toy Story is perhaps one of the biggest movie franchises of all time. People older than me grew up with it, and there will now be little kids who are about to experience Toy Story for the first time this year. It's great. We all love Toy Story, but how well do you know it? While I was reading about the latest movie coming out, I stumbled across some pretty strange theories about Toy Story. The more I looked, the darker they got. I thought I'd pick the best 10 out for you today. My name is Danny Burke, and this is the top 10 scary Toy Story theories. Starting off at number 10 now, we have Same Faces. At the end of 2017, The Mirror posted an interesting theory about the original Toy Story movie. Have you guys ever noticed how similar the faces look in that movie? Now, when I say that, you may think I mean the toys' faces, right? I mean, they're all basically plastic toys in real life. Plastic toys all kind of have that similar vacant expression, a bit dead behind the eyes. However, this story pointed out that the toys actually had quite different looking faces. It was the children that looked creepily similar in the original Toy Story movie. Early on in that movie, we see Andy playing with his toys. Later on, we see Andy's friends attending his birthday party, and they look very similar to Andy. Like, almost identical. They also look just like Andy's neighbor, Sid, the boy who likes to torture toys. What's going on here? Why does every kid in this movie have the same face? Some people say this is just a product of animation at the time. Although Pixar's animation still holds up almost 25 years on, it was still limited by what they could do. Perhaps that is the reason. Others say that this isn't true, because they managed to make the toys look all so unique. Some say that the humans in the movie are actually the toys, and that what we think of the toys are really the living people.
Who needs sweatbands? Thanks to Old Spice Swagger Antiperspirant, I don't. You want to file free? Hit. this year our holiday commercial is just stuff I picked up for $5 from the yard sale. Oh, good.
We're still. You can get your head around that. That would also explain why they're able to move and talk, but it also produces a whole bunch of other questions. Next up on number 9 now, we have Andy's father. Fans of Toy Story will notice the absence of Andy's father throughout the Toy Story movies. Some people say that his parents just weren't together, or maybe they split up, but others think that Andy's father died. One Reddit user suggested that Woody was the last toy that Andy ever received from his father before he died. Andy's mother noticed how much Woody helped Andy through the grieving process, and so she kept buying him more and more toys to help him deal with the pain. This is why Andy's toys remained in his toy box even when he was 18 years old. They weren't just toys to him, they were his last connection to his father. Now, despite all of this, Andy decided to give them away when he went to college, and we see how much it really hurts him to do that. If this theory is true, then the toys in Toy Story helped fill a very dark place in Andy. They were much more to Andy than just childhood toys. Moving on to number 8 now, we have The Immortals. This is a very weird theory that came from Reddit and was written by Nameless.
I don't care. You can carry it up and put it in a bottle, or you can use it for a waste basket if you want to.
Oh, well, I thought there was some stuff in there, but like a waste.
I'm watching YouTube. Just wait. Teacher do something. Wano! Look at there!
Well, I gotta have to go get that.
Something happened.
2:35.
The class over! And I'm doing absolutely nothing!